The forms of an extensive the Cretaceous period.
To welcome, we would like to invite Dr. Deepak Gupta to present a sapling to Mr. C.B. Arun Kumar. Mr. C.B. Arun Kumar. He's an academic director at Edge Metaversity.
Recording in progress.
Please welcome him with a round of applause. Thank you, Deepak.
उसका बंदे एक चल
May I now invite Mr. Ashish Sharma to please present the sapling to Mr. Abhiral Kukureja. He's an Assistant Director, Head of Admission, Edge Metaversity. If Ashish sir is not there, Dr. Ashish Sharma, could you please come up to the stage?
वीडियो पे ही जा रहा वीडियो को ऑन करो
Mr. C.B. Arun Kumar, Academic Director, Edge Metaversity, has been working in the animation and visual effects industry for over 30 years. He started when he got his first BBC microcomputer and used it for creating graphics for India's first science fiction TV series, Space City Sigma. He also worked on the very first Indian 2D animation series for Doordarshan called Gaya Baya. He graduated from the Mass Communications Research Institute in Delhi and has worked in various capacities in the In 2005, he was awarded the National Award for Best Director of an Animation Program for Kachua or Khargosh, an episode from India's first 3D animated series for Cartoon Network, based on the Panch Tantra. C.B. Arun is passionate about teaching and was the co-founder and academic director of FX School, a leading film and VFX institute based in Mumbai, where he pioneered the use of DSLRs in low-cost feature film production, working with noted filmmaker Ram Gopal Verma. He's a Unity certified developer, an Unreal Engine fanatic, and ardent Blender 3D enthusiast, as well as an award-winning 360-degree VR photographer. His current obsession is virtual production using Unreal Engine, which he believes to be the most important developments in visual effects for movies since the development of computer graphics. We invite you, sir, to deliver an expert talk on building digital twins and metaverse with Unreal Engine.
Hi guys. I hope the mic is working. Is it working? Yeah. So the first question is, how many of you know what is Unreal Engine? Okay. And how many of you play games? Ah, nice. Okay. So how many of you play games made by Epic Games, which is and on Unreal Engine? That's like Fortnite, PUBG, all these things. So yeah, the whole concept of smart cities, digital twins, this thing has been a very scientific concept which has been there for a very long time. Okay, and lots of money, Microsoft and all these companies were putting lots of money in making very, very, very expensive solutions for all these concepts. They were custom solutions. Every smart city had their own custom solutions. And this is the background. It was a very scientific. And on the other side, we have Unreal Engine, which, as you know, is what? It's a game engine. So how did the two of them meet? How did gaming meet science? Okay. And as you can see, I am wearing an Unreal, Fest t-shirt. So what happened is something called real-time 3D graphics. The real-time 3D graphics, which basically every gamer knows, you have a AAA game, you'll have a graphic card in it. Oh, I want an NVIDIA graphics card, RTX 3080, 3090, so on and so forth. So we know the power of these graphic cards. While these graphic cards can be used to play games, people realize that the power of this technology can be used in various other places. So one such solution was to make the whole concept of how to make digital twins, which we'll talk about, much easier. Literally, the problem was very massive, and it's with the technology from companies like Unreal Engine and Unity, particularly Unreal Engine, that this challenge has been overcome in a very visually pleasing way. So you're not just seeing some diagrams with lots of indicators from sensors, which are like, a very scientific kind of a thing. You're actually seeing something very beautiful. So this particular picture, is it a real city or is it a 3D city? Yeah, it's actually a 3D city. So next slide. So what's happening is, let me play one this. So there are these companies that build the what we call 3D part of digital twins. So I'll first play this. Iska volume कहाँ है? When the video started, how many of you thought it was an actual aerial shot? Honestly, batao. है ना? So what has happened in the last 4 or 5 years is the quality of imagery you can produce with these Unreal Engine kind of game engines is so incredible, it's become photoreal. And what is happening is you can build vast cities. With Unreal Engine, you can download for free. You check it out. If you have a lot of RAM and lots of good graphic card and lots of memory and lots of hard disk space, you can download a city demo. That's a Matrix movie का city का demo है, the city of Matrix है, New York that city उसका demo. That demo runs engines like. So on one side, there has always been science. But the thing is, today you have science which has got married with the attractiveness of gaming. You're not hearing at the back? Okay, wait, sorry. I didn't realize that. Normally I'm too loud. So, so this is what has happened here. One side we had gaming, which was like parents would say, please don't play games. It's very bad. Okay. Now what you realize is gaming is going to revolutionize the whole world. Metaverse is built on games. Our digital twins are being built on games. So this whole concept of where, you heard about Web 3.0, the next avatar of the internet. Game engines have become a very critical part of it because this is one of the differences that we're looking for. So this company, Build Media, it has done something that they have, the city of Wellington in New Zealand, they made a digital twin of, you saw that. So now, all of you who travel the roads of Delhi and Gurgaon and all, you know how many problems you have. Your potholes, bridges are not complete, things like that. So what is the concept of a digital twin of your city? The idea is that we will take every single road, building, facility, and we will make a digital copy of it in the computer. Now, all this is only as good as the operator, but today you have actually Google Map, even though sometimes Google Map doesn't do things correctly, 99% of the time, you can get anywhere using Google Maps. I mean, once in a while it makes a mistake. But it is a lot better than asking, "Bhai sahab, kahan pe hai?" "Nahi, idhar jao ji, udhar jao." Pehle to sab ghumte rehte the. So now you have Google Maps. Similarly, the next level is going to be these business stores. So if there is a pothole in a place, it will suddenly show up on my digital map. If electricity goes out in a colony, it will show up. If the air pollution level changes, it will show up in your digital twin. So whoever is a city planner, and this is obviously working very well in very advanced countries, but it's the thing we want to do. We want to be able to, first thing you have to see is, can I get the data? If I don't get the data, there's no way I can actually find a solution. 9 out of 10 times we can't find a solution because we don't even know where the problem is. So I think ma'am said just before we started that it's using the Internet of Things. So you're using all these sensors that you place in the environment. And these can be all kinds of sensors. These sensors connect in real time to not just some data machine or not to some cloud storage. It also connects to what? This virtual city of yours, which you can sit. आपने देखा बंदा ऐसे करके उसको घुमा रहा है, city देख रहा है. So suddenly an alarm will come. It's almost like a science fiction movie. Alarm will come कि यहाँ कुछ हो गया. You can go there, you can see, you can say send resources. This is the concept of how you have an interactive real-time management of your city. Anything that goes wrong in your city, you can see and now. Let's go to the next slide. So what is a digital twin? This is what we are talking about. Digital twin of your city. It's not a blueprint. It's not a schematic. It's not a picture or a movie. Abhi kya hota hai? The manager will say, or mayor who will say, I want a report. So how do you get this report? Somebody goes shoots a video. They take a picture, or they look at the blueprints of the city. है ना? Schematic. This is the traditional way of looking at things. All the 2D kind of things. We look at this and we say, okay, let's find out. There is a fault. Where is the plan? Let's find out the plan. Let's figure out what. We want to replace this with live visual representations. And that is why people who do all this stuff like me, who are animation people, we comment. Because I'm not from the science end of it. I'm from the visualization. So this is a marriage of multiple type of people, and we'll see how all these people have to work together to create the digital. It's a live visual representation of the components and dynamics of how a man-made system is planned, built, operates, and works through its life cycle. काफी सारी चीजें हैं इसमें. So one is, I kept telling you that we can spot problems. But the first thing you start doing is, if I have to plan a new building, what were they looking at? They were seeing कि इसमें एक नया metro route we have to put through the city of Wellington. How do we plan the metro route? It's being done virtually first. It's not being done कि let's start digging up somewhere. Then you are saying, yeah, why have you dug up? They'll say, yaar, first they plan everything, all potential problems are seen virtually. Then you go and do it. This is not just happening with cities. People are doing it in medicine. complicated surgeries also we are trying to do virtually. That's a different, it's not part of it. So that is what it does. So you can start planning and you can build it. You can see how it's getting built. As it operates, your sensors are giving you real-time feedback. Many of these things are already there. Now, if you are running a metro or a train or something, there is some control station where you know where the train has gone. You can see where the train is going. But suppose you are actually now seeing the actual 3D model of the train running. So if I were to go into this, if I make a digital twin of Delhi, I go down and I'll see Delhi Metro, I can see the station and I'll see my metro train running as it is running in the actual line. And if there is a problem with that train, it will happen in my digital twin also. This is the concept that we are looking at. Matlab, not all parts of this will work immediately. It's a utopian kind of thing. They want to do everything in it. But step by step, literally every piece of data you want from your live city will be replicated in your digital model. And once you have that, you have like a very, very good eye view, bird's eye view. How many of you play games like SimCity or things like that? So imagine it's like SimCity. You are saying, I'm the mayor of Delhi, I'm sitting here and I'm saying, Acha, ye building yahan karke ye kya ho jayega? So it becomes like that. It's not like, a chain of things where you have to go to 10 people. It goes to some clerk who will go looking for a file. No. The people who are managing it will have a very good view of it. This is the concept. So where are the three things where it's coming? The digital twins, you have architecture, engineering, and construction. Today, these are three big guys who are actually using the whole concept of digital. So, and how does this operate? It operates by connecting the data from your IoT sensors to the 3D digital twin model in real time, creating a working simulation of the real world events in your digital. This is what I was telling you. So this is how it works. And what is its utility? This is again what we've been talking about. It gives us real world feedback on how a system is functioning, enabling performance improvements through learning. There is no golden, no silver bullet, things don't get. But suppose you are saying Yamuna level is rising. Okay. And in my digital twin, the sensor that reads the level of the water will start predicting what level the water will reach, how much of the bank it will overflow. So if I'm saying, okay, the water is rising at 2 inches per hour or 1 inch per hour, that's a very high rate. I can get the computer to immediately say, agar ye rate chala, so how much water will come in 4 hours, in 8 hours. It will show how much area will get submerged. Same way, if I'm getting a certain amount of rainfall and I want to see what will happen to my city if this rainfall continues at this rate, it will be able to tell me. So we get not just real-time reporting, we get a chance to use the computer to do this analysis also. I'm having a problem. What will happen if this problem goes at this? What happens if the water level actually starts dropping? All these things can be worked out with this. Project management is very, very easy with this also. So this is a kind of a diagram from one of the Swedish companies that does this kind of a thing. You can see it's a whole office connected to the building that's connected to the services. Let's go to the next slide. So this is the whole picture of that. So this is one of the companies that PSP discussed. These are 5, 6, or 7 companies that are doing this on a massive scale. Anybody who starts as computer science students, suppose you say, I want to start trying something like that. We don't do what we saw in Wellington. Na? That's millions of dollars. So what do? We do a prototype. We do a small project. हम कहते हैं कि चलो, the easiest way to do it, okay, there is my house. Let me see how many sensors I can connect to my house, and sitting somewhere, what all I can find out is happening on my house. If you can do that, you have at least got the knowledge of how to do this for a larger and larger environment. It's only a question of getting the money to do it, to put the sensors to do it. So anybody who wants to test this idea, it is not that complicated. Obviously, when you're putting the whole city into the internet, it will be very difficult. But if I say I've got a house, it's got 4 rooms, you know, all its bulbs are now connected. All its things I want to connect through the relevant kind of equipment, I connect it. I create a digital model of it, which will run even on my computer or a laptop. I don't even need to have a new server. It will run on it. I can test this. I can test what is the interface, because we'll see. I mean, this is not a class on how do we do this on Unreal Engine, which is actually, at least 3 months of learning. But next slide. This is another digital twin. This Changi Airport. Let's see this.
Hi, I'm Yin Jie from BAUS. We are a design agency based in Singapore. BAUS is an assemblage of architects, programmers, and game designers. We use game engine in the architecture and built environment sector on a wide range of projects, ranging from residential to commercial and even to heritage. Our projects are often tailored specifically to the needs of the client, and we deliver from the conceptual stage all the way to development of the software, as well as maintenance of the project after it's completed. Today, I'm very happy to share with you our project with Changi Airport Group, the Changi Airport Digital Twin. BAUS has always been a partner of Changi Airport Group since 2017, and we developed a digital twin of Changi Airport over the past 2 years together with Mr. Ao Ching Wen and his colleagues from T5 Planning. The digital twin is around 1,300 hectares, and that is roughly the size of 3,200 football fields. Our approach to digital twin is to build a data integrated model. We stream in live operational data into the 3D model, and we use that as a base to develop applications for different end users of the airport. The reason that we chose Unreal Engine is because of its ability to provide real-time graphics, but at the same time, we can integrate with back-end databases. And this allows us to scale with the size of the project. Throughout the 2-year period, we deployed to different platforms and applications from the same project file. The base model was built based on CAD and BIM information. The 3D models are constructed modularly and assembled in Unreal Engine to take advantage of the many optimization tools often used for open world games. This includes instancing as well as the polish tools. This is important because on a project of this scale, your performance is key. Using georeferencing, we align the model with real geocoordinates that allows for integration with sensors and data. With blueprints, we build integrations with the Changi backend databases that streams in live data and projects them onto the model in real time. To talk a bit more about the technical details, let me invite the next speaker, Poon Hei, who is our senior developer of BAUS.
Hi, I'm Poon Hei, a senior software developer at BAUS, talking about our application which uses aircraft transponder data to visualize the position and movement around the digital scale model of Changi Airport in Unreal Engine 4. The application can display plane position and additional information in real time, relayed from a server in the airport. It also allows users to play back historical simulation records transmitted from the server itself or from records stored in a local database. Going forward, our future plan is to integrate as much information as possible into the application to serve as a central hub of information for monitoring purposes, such as arrival and departure times at each gate, human traffic counters, temperature and humidity sensors, and so on.
Thank you, Poon Hei. That was an example of deploying the digital twin on a macro scale. On a more micro scale, we investigated the road and traffic infrastructure from the angle of the actual user by deploying the digital twin onto a driving rig. We showed that the detail level can be achieved with ground level signage and markings. With this, end users such as technical staff and operators of the airport who may not be familiar with architectural drawings can be engaged to test out the digital twin. This opens up opportunities with the complex tools that Unreal provides to build scenario training and design validation applications. This is especially important in today's world where digitization and remote training become increasingly important. The digital twin is currently deployed internally in Changi Airport. It is meant to be a live model, which is consistently updated with new content and features. This project serves as a foundation for Changi Airport Group to continue exploring digital transformation in the domain of airport planning, simulation, and operations. Thank you for listening to my presentation. I wish you a pleasant evening and please enjoy the rest of the events. Thank you.
This accent is a bit difficult to understand all the time, but I think it's pretty clear what we were talking about. You have the whole Changi Airport, which is like a massive airport. Okay, and they have created, you saw the model of the Changi Airport inside Unreal. So all of Changi Airport is there. The data that comes from the aircrafts, where they are moving on the runway, everything is being conveyed to the display. So you can see the data at many levels. You can just see the thing working. It's not a simulation. You can see the real-time working of this, or you can see it with lots of, layers of information. You saw every car entering the, parking was getting spotted. You could see the car is coming. Same way, every plane was being spotted. Now, these projects are also in what I call their infancy stage. As more and more sensors get applied, more and more things will start coming out. They may be able to track your baggage as it goes through. How we incorporate digital tagging into their system. Now, a lot of if you have an Apple, have you seen the tags that you can use? It's a little disc you can put, and even if your bag gets lost, you can locate it. So today, the technology for actually locating phones, items, these kind of things are very easy to have. So one is where we can locate something, and another thing is where that thing is also talking back to us. So obviously, when we are looking at things more complex like an aeroplane, there's a two-way communication system. Some of the items may just have a passive communication. Like if it's a luggage, I may know where the luggage is going. And they could do this just like we have our, smart these things when we are going in our car. The same way they'll put your luggage tag, and then the system will be able to track your luggage. Where is it going? How is it going? By reading its, its code data. So these are the kind of things people are doing. And again, like I said, why I'm here to talk about this, that this is happening increasingly and crazily on a game engine. And 4 or 5 years ago, nobody would thought this would happen, that this kind of visually rich pictures you can get. It is one thing to say, I've got a graph-like thing, usme kuch chal raha hai, kuch chal raha hai. You see, all this reporting from machines has been happening for a long time. What is the difference? Can somebody tell me? What is the difference that is happening now? What is it that we are seeing today which is different from, say, how we gain knowledge about system functions through Internet of Things and things like that, the earlier avatar of our, creating such smart systems? Yeah, actually, it's just become realistic 3D. And this is again when we are talking about the web transitioning from web 2.0 to 3.0. What is happening is what was just a passive 2D readout has now become an interactive 2D readout. And this has just begun. I mean, it's today, why there is an opportunity for all of you people is because today, I'll show you 6-7 companies doing this kind of thing. Tomorrow, everybody will be doing this. Isn't it? And when everybody is doing it, it's just like another IT revolution. So these kind of things are going to be another part of the metaverse. So when we talk about like what Mark Zuckerberg says, meta ho gaya, people are jumping around. I mean, that's one aspect of the metaverse. What is the metaverse? The metaverse is a new avatar of what our whole worldwide web is going to be. It's going to be immersive. It's going to be 3D. So this is what one of the things will be. You will have digital twins of all kinds of things you can check on. So whatever life we are leading in real life, there is a parallel to it in the metaverse. Next slide. So what do we need to create twins? Basically, we need a multidisciplinary group. Okay. Architects are very important in this. So one of the things you need is an architect, because architects have very good idea how to actually do AutoCAD and CAD work on how buildings will be there. So an architect who is very good with this kind of work will be ideal for it. You will need those people who do computer aided design. Obviously, engineers, hardware, software engineers of all sorts, but mostly people who are looking into Internet of Things, or any kind of remote sensing technologies, all these things are going to be very critical to creating this. So that's your second type of people. If you're using Unreal Engine, in Unreal Engine, there are two types of ways you can program Unreal Engine. One is a visual programming structure called blueprints, which I use. And if you come from an engineering background and you have C++ knowledge, you can actually get to the core of the system and program it to do a lot more. Okay, so you have these programmers who are doing very specific things. What are they doing? They are trying to write all the code that will glue the data that is coming from the real systems inside my 3D environment. So this interface key, I'm getting the data from somewhere. How do I route it? How do I put it into my machine so that it accurately shows the results? And of course, then you have people like me who are what we call Unreal Engine technical artists. I'm basically like, when somebody, read out my CV, you realize I've been doing animation and things like that. We are the people who look into how to make all the technical and architectural data look nice. It's all about looking awesome. It looks so real, you won't be able to tell. All of you saw these 3-4 examples. The Changi airport looks less real, but this city looks so real. Wellington city looks like absolutely photoreal. It's crazy how real it looks. And it's only going to look better. So these are the 4 types of people. While I say on one hand, you can put both engineers together, but I'd rather not do that, because I think engineers who spend a lot of time in game engines start having a particular bent of that. So you need people who understand Unreal Engine and how to program Unreal Engine. And there's a lot of knowledge on how to program Unreal Engine, who are different from people like us who teach you how to use Unreal Engine to create photorealistic images. So there are like multiple disciplines that comes in. There is architecture. There is, all the engineering that you're doing. There is people who are doing specific coding work to one software. And there are people who are doing the artistic work. So when all this, you put up a team with these kind of people, you are able to create these kind of, digital twins that actually give you a lot of valuable feedback. So in this case, they were looking at, like you saw, they were looking at creating a mass rapid transit system in Wellington. And the problem was, city is already there. How do we build a new line? So you can look at the whole thing in 3D and start giving options. And you can see what are the problems with that. Next slide. So this is how we actually do it in Unreal Engine. First thing, obviously, हमें पता लगाना क्या करना क्या. What is the purpose? Okay, what is the purpose? Then we have to get a 3D model. Now, 3D models can be got in multiple ways. You can do something called photogrammetry, which you scan things, when you reduce it, you can do that. You can model the objects. You can buy them certain things. And then you have to identify the data sets and data sources that you need to route into your 3D model. And then you do a build in Unreal. So these are, again, the 4 steps to creating your display. Once you have figured out what you need the display for, because you can have a laundry list of requirements ki mere ko 100 cheezein karni. Chances are when you build that much of complexity at first go, it will fail. So most people build a prototype, they test say only 2 things or 3 things. And when they know this is working and the reporting is good, they keep adding things. I first need to know if my plane will come and when the plane is coming and leaving and how much time. So I have a much smaller set of things. Acha, plane to ho gaya. And a plane is the most important thing. Then I'll say, where are the passengers? Then I'll say, where are the bags? Then I can keep on going more detail. But when we start with the problem solution, we try to not have it so complicated. When you're seeing something like that, Wellington, you're seeing something that's gone through many iterations of complexity. So it's already looking complex. So if you're trying to do something, don't start with a very complex problem. You'll only get failure. Start with a simpler one and see how it can be complex. Next one. One of the things that's going to happen with this kind of thing is how many of you know what's extended reality? The concept of extended reality. You all know what is VR? Anna? Everybody knows what's VR? Virtual reality, you put headsets and you're completely immersed. How many of you play Pokemon Go? Okay, some of you have played. So you know what is AR. Huh? That's you have an AR lab or something, augmented reality where you test with phone or AR kit or something like that. So you got an idea of AR. So once you actually live in a world where you're real, you have augmented reality, mixed reality, virtual reality, all these things are there. We call it extended reality. What is happening is my life is getting extended into the metaverse. I am getting extended into the metaverse. So how is this different today? You spend a lot of time looking at your phone. Eventually, there'll be a chip they'll put here and you'll be able to get a direct readout of whatever is happening. By that time, you're already a different kind of human being. I mean, I'm saying this is going to happen maybe 100 years from now, maybe 50 years, we don't know whether it comes. But people are working on it even today. How to actually connect your, do a neuro connection to your digital circuitry. So we are all becoming more and more connected. It's very, very easy if you go like and I was telling somebody, go in a family to a restaurant, you will find, say, father, mother, 2 kids, सब अपने phone पे बैठे है ना हेलो तुम रेस्टोरेंट में क्यों आए हो यार but क्या है यही है we all are on our phones so if we see on a random everybody will be on their phones it's how we live today. Imagine this becoming 20 times worse or 20 times better whichever way you want to do and that's how immersed we will be and suppose I now want to see when is my flight leaving. Oh, my wife is on this flight. What is happening to it? I'll look into it and I can see a 3D version of her flight taking off. Instead of just saying departure, ho gaya, nahi hua, hai na? So all we are doing is we are creating a more visual layer to our experience. It's not like we don't have the data. Today we have the data, but that data is becoming more user-friendly. It will have a visual impact on us. I can see, okay, there my flight is taking. So in some flights, if you say those going abroad, they have 3 cameras in the plane and you can see below what's happening in the plane. You can see from the, wingtip, you can see. So you have 3 views, you can see outside what's happening. It's really amazing. I don't watch any movie in the flights now. I just look at that camera. I only stop looking when the plane goes above the cloud because it's so fascinating. You will see everything going by, different views. It can be quite interesting. Of course, once you go 40,000, 39,000 feet up, then you don't see anything. All you see is white and blue. But otherwise, it's quite fascinating. You're taking off on a good thing. It's interesting. So, what we are looking at is that even all these things, when we talk that 4 or 5 types of people are required, these people will be collaborating on it. You can say, I'm doing this. I have an expert who's a friend who's like, say, in Netherlands, and I have another expert in New Zealand, and we are all now in this extended reality. We are trying to find out how we can build that. Next slide. So the image on the left is that I've become really fascinated with artificial intelligence. So these are prompt-based. I've not drawn or taken the photograph. I make it in something called mid-journey. So some of the images you will see, these are mid-journey images. So I write, girl with VR headset, this thing, it produces this image. Okay? So you can see already things like that are happening. So मेरा दोस्त है, वो artist है, वो कहता है यार हमारी तो नौकरी चली जाएगी, तू तो बैठ के कर रहा है. You are making this picture, what will I do? They still requirements. But it's a fairly realistic picture made by a computer, artificial intelligence. So what do we need for the twin? We need individual models from backgrounds. Anything that involves construction needs architects who are experts in computer aided design. So we have talked about that. You can also get these 3D models from GIS data. Very simple 3D models for not typical building for real estate. So sometimes I'll say, okay, मेरे को पूरा city चाहिए, but I only need to monitor 5 buildings or 7 buildings or 8 buildings. So I tell a 3D modeler, please make this in detail. Baki sab, I can just take off the data and I can extrude it and make it. This is what I've been saying all the time. Build a small prototype. Don't try to make a very large print because that's going to fail. So once you understand all the way machines talk to each other, the consistency, the lag, the efficiency, the error rate, and all these things, once you solve that out, you are very certain this is working. Then it's very easy for you to start scaling it up. And many people who do this start घर पे करते हैं. अब पता नहीं मम्मी पापा क्या बोलेंगे. जब मैं when I was your age, I used to open up radios and TVs and things like that. And now you guys can start connecting things to fans and AC and all, and your parents will be unhappy because all kinds of funny things will start happening. अरे ये fan क्यों चल गया? अरे ये light blink क्यों कर रहा है? नहीं मम्मी मैं try कर रहा हूँ experiment. ये सारा automatically चलेगा. But whatever it is, you can control all your stuff. It's very easy. These things are very easy. You can easily do it, and then you can see if you can create a digital twin of your home, and you've got a prototype. Now you can take it to somebody and say, boss, I'll now do this for a whole block. I can do it for a whole city, so on and so forth. Because it's just building up from there. Next slide. This is more technical. This is actually, there is something called DataSmith that we use. That's why I'm not talking about details of what we do in Unreal Engine. I won't do that. So what happens is these are all things in which we create all our assets. PDS Max, Rhino, SolidWorks, SketchUp, Katya, all these things and all the other formats. So if you want all this data to go inside Unreal Engine, Unreal Engine mein kaise jata? There is a translation layer. You feed this data and it will convert it into usable imagery for your film. So this is something you can do. And as I said, in Unreal Engine, though I'm talking to engineers, so I won't say that. When I talk to artists, I say, bahut acha hai Unreal Engine because you don't need to program in C++. You can do visual coding with blueprints, But you guys are already good in C++, you can do that. So it has a dual way of talking to the system. I can code and I can create blueprints, and now I think you can also use Python. So there are 3 ways to do it. So next step. Okay, play.
This technology firm in Beijing has created a complete virtual clone of China's largest city. Covering almost 4,000 square kilometers and built using information from satellites, drones, and sensors in the real Shanghai, the digital replica could soon have the power to simulate events in the city's future with astonishing accuracy. Powered by Unreal Engine's photorealistic graphics, covering thousands of buildings and with the potential to impact millions of people, this is how China cloned Shanghai. The extreme rise of technology over recent decades is now having a major impact on how we shape our cities. Faced with several challenges, from the huge growth of urban populations to climate change and pandemics, these centres are now using connected digital information to improve services, plan development, and optimise buildings. But digital twins take things to a different level. These models are precise virtual representations of physical assets that are kept continuously up to date and could cover anything from one small element of a building to an entire city. That's what Beijing-based developer 51 World is planning to do with Shanghai. Powered by Unreal Engine, the team has created a complete virtual model of China's largest city that covers an area of more than 3,750 square kilometers. Though the level of detail varies across the model, more than 20 landmark structures, including the Oriental Pearl and Shanghai Tower, were created individually. Countless other buildings, roads, waterways, and green spaces were then made using an algorithm that converts data from a geographic information system into 3D information. 51 World's intention is to turn this model into a digital twin, a virtual reflection of the live city that is continuously updated in near real time as it gathers data from geographic information sensors, satellites, drones, and other sources. It could allow its user to control a building's systems, monitor traffic flow, or show citizens how a planned new project might appear. With digital twins, designers can simulate ideas in the live city environment before they are constructed, and the impact of decisions from where to position a bus stop to how large a new housing development should be can be understood in advance. 51 World's models of other cities are already being used to create digital twins. Perhaps its best example yet is in Singapore, where one has been built for a developer and the local government. Integrating information on buildings, transport, parks, drainage, and more, it allows city operators to monitor traffic, building operations, bridge maintenance, and to simulate floods. 51 World has also implemented several intelligent transportation projects across China, offering solutions for 3D real-time monitoring and micro-traffic flow simulation. To optimize the efficiency of real-time rendering in the Shanghai model as a user moves across the cityscape, the entire simulation is divided up into 2 square kilometre segments. Closer objects appear in finer detail, showing accurate environmental reflections, soft shadows on surfaces, and lifelike shading effects in accordance with the weather. To achieve these graphics, 51 World turned to Unreal Engine, one of the industry's leading platforms for creating photorealistic visuals and immersive experiences. As well as cutting-edge rendering capabilities, Unreal Engine gave 51 World a real-time lighting system that simulates the sun, photorealistic models of the city's landmarks, and the ability to quickly find errors. Digital twins in the hands of a private company or a national government instantly raises questions about rights, ethics, and ownership. All of the data used in systems like this is anonymized, and facts about specific individuals and their movements aren't tracked. It's more for looking at broader, trend-level information. Notwithstanding that, the exciting advantages these digital twins bring come entwined with challenging questions for our societies. Though the Shanghai model is undoubtedly one of the most advanced we've seen, several other cities are now exploring the idea of virtual twins, albeit by creating advanced 3D models rather than true digital twins. In Finland, VR studio Zoan used Unreal Engine to create virtual Helsinki, a digital replica of the capital that's used for everything from 360-degree virtual real estate tours to promoting the city at international exhibitions. And in New Zealand, Build Media and the city's council used Unreal Engine to develop an accurate model of Wellington. They now plan to integrate live data to create a true digital twin. Though any SimCity or Minecraft fan will tell you that building city simulations with a gaming engine has been possible for decades, this technology is now on course to transform our real-world urban landscape. What's more, digital twins are still in their infancy, and their potential is enormous. With future models expected to be capable of autonomous decision-making, it seems that the age of the truly smart city has only just begun. 51 World's model of Shanghai was brought to life with Unreal Engine. To see what else is possible with one of the world's most powerful visualization tools, click the link below. And as always, if you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1 app.
That was like all that you have to kind of know was already there in it. So they've gone over it. There are, like I said, next slide. These are some of the companies we've seen things from their Bows, India, business, North Dogs, cognitive remote. You will start seeing that 25-30 companies honge total who are actually doing anything of this kind of scale. But lots and lots of people are actually in the infant stages. And I think this is somewhere where there are going to be huge job opportunities for people who are both scientific and creative to understand both visual and scientific sets of data and things like that. So this is going to be very big because on one hand, you also, like he said, there is this challenge. There's this book in the 50s by George Orwell called Animal Farm, and another one called 1984. So the thing is, there was a term from 1984, Big Brother is watching you. Ab yahi ho jayega ki, one of the minuses of all this is that you literally don't have any privacy. You know, people can know where you are all the time. They'll track you. Where is your cell phone going? So all this is going to be the future. Okay, I think that's all from me now. Okay, any questions? Yeah. No. Okay, cool. Thank you, guys. Yeah, go ahead. See, what you're saying is absolutely correct. There are two problems with it. One is the security of the system itself. Hai? So now people who want to sabotage things will not go and say, patri ki fish plate nikal do. They will try and put a virus into your system so that your reporting will go wrong. I mean, we have seen that in movies also. No? You can change the signals, red light. So any technology will come with these dangers. There is that danger. And there is a danger of decreasing privacy for individuals. The government or any other third-party people can start watching you, and it's quite scary. The more digital data you carry, the more transparent you are to the world. These are the two minuses. I mean, and they will be there. Anything, every device you have here, it's like, you get a phone call. I mean, everybody has seen some of these TV serials on Netflix and all. You realize that someone sitting in Bihar can actually skim money off you. So security is, wherever something comes up, there will be thieves and there will be disruptors and all that will happen. But it doesn't mean technology is going to stop. I think the technology will go there. If the digital tool is controlling the architect, yes, that will become like Terminator. Na? See, these are all, Elon Musk himself has said, the dangers are all there. When we go to this level of technology, we ask what happens if your digital twin starts becoming sentient and it starts controlling you. It'll be very scary. So that's all I can say. It's very possible it may happen. Yeah, hi. No, Unreal Engine is a full-fledged application. What you do is you have plugins. So you can get plugins for specific things. So if you want to write your own plugin and you're a coder, you can write your own plugin. There are already available certain amount of plugins. Most of them are free from GitHub, you can get, or from the marketplace you can download. So for basic things that are there, if you're an engineer, you start writing custom plugins for custom communication. Okay. Okay, guys, thank you very much. Okay. Oh, wonderful. Awesome. We are actually what we call an institute that teaches creative technologies. Okay. So when you looked at the 4 people in it, we teach you how to do all this stuff on Unreal Engine. We don't teach you engineering and we don't teach you architecture, but we teach you how do you create the digital twin in a computer. If you want to, how do you learn the software to create things like that? So that is the end which we teach. We teach one of the pillars of the metaverse. As us, I mean, we are part of Global University Systems, which has a university. So university is teaching computer sciences and things like that. We are teaching creative technologies. So what is the visual end of your data? How do you visualize your data? That is where we come in. Whether it's digital humans, whether it is twin cities, whether it is architectural visualization, product visualization. So we teach all things related to animation, visual effects, look development. So the kind of cities you saw people building, how to build that is what you teach. Okay. How to light it, how do you use Unreal Engine to get that kind of effect. The rest of it is core, technology courses, which we don't use. Okay. So we are teaching them wherever technology meets, because everything we are doing is happening on software only. Where does it meet creativity? So we are at that end of the Okay. Thank you, guys.
Thank you, sir, for these for your valuable and encouraging talk on digital twins. Indeed, we all will get benefited with this. Now, Professor Brahmjit Singh, Vice Chair, IEEE ComSoc, Delhi Chapter. Professor Brahmjit Singh, Senior Member, IEEE, received BE in Electronics Engineering from Malviya National Institute of Technology, Jaipur, ME in EC, Microwave and Radar from Indian Institute of Technology, Roorkee, and PhD from Guru Gobind Singh in the Prestha University, Delhi. He is serving as professor with EC department at National Institute of Technology, NIT, Kurukshetra. Presently, he is the Dean Planning and Development, Regional Academic Center for Space, ISRO at NIT, Kurukshetra. He has published 181 research papers in international and national journals and conferences, published 1 edited volume, and co-authored 6 book chapters. His current research interests include microwave technologies, machine learning and wireless communication, 5G and tactile internet. He is the recipient of the Best Faculty Award Administration 2019, conferred by NIT Kurukshetra, and the Best Research Paper Award from the Institution of Engineers, India. He has been a regular reviewer for several IEEE journals and conferences and has been serving as the TPC member of various international conferences. He is the fellow of IETE and senior member of IEEE. We welcome you, sir. Now I would request Professor Brahmjit Singh to address the gathering. Over to you, sir.
Hello. Hello.
Sir, you are audible. You may start your session.
Sir, you are audible. You may start your session. Okay. Thank you. Thank you. And namaskar. Distinguished guests, delegates in the symposium, faculty members, dear students, ladies and gentlemen, I wish you all a very good morning. First of all, I congratulate the organizing team of this international symposium on smart cities, challenges, technologies, and trends, which is being organized in joint collaboration of MAIT Delhi, NIT Delhi, and of course, IEEE Communication Society. The organizing team has chosen a very interesting topic for the symposium, and that is smart cities. In the past, the word smart had been used for people. We call some smart people and some people not so smart. But now, the physical objects, things, machines, infrastructure, and up to an entire city are being made smart. How much smart these things are or will be, that is debatable, but for sure, they are being equipped with certain decision-making capabilities. They are taking the decisions without human intervention. And this fact, basically, they can take the decisions, and this fact makes these physical things and physical infrastructure is smart and intelligence. This aspect is being made possible and feasible by the intervention of cutting-edge technologies, prominently Internet of Things, communication infrastructure, plus AI/ML. Technically, the idea of making a city smart is implemented by deploying an array of sensors in the infrastructure, collecting the data through these sensors, analyze this data, and derive, or let us say infer, the intelligence from this data and take the right and timely action. We all know that urbanization is happening at a very fast pace. In India, rural population is around 31%. At world level, at world level, 54% population live in cities. And as per one projection, by 2050, 66% of the population will move to the cities. The city infrastructure may not handle this transition. There will be huge pressure on the city ecosystem in terms of environment, social, economic sustainability. The problem is how to manage the resources and deliver the services in such an environment. The concept of smart city provides the solution to urbanization challenges and problems. The smart city mission aims at improving the quality of life of the people together with much needed economic growth. How to provide the necessary infrastructure, physical infrastructure, institutional infrastructure, social as well as economic infrastructure. The task of converting a city into a smart version or establishing a new smart city is gigantic. The ecosystem of a city involves e-governance, lighting system, waste management, water quality control, water management, sanitation, public transport and mobility, congestion control, parking loads, so on and so forth, and digital payment for utility and so on. In a smart city, the technology is leveraged to provide the innovative and intelligent solutions to these functional and operational issues. For example, in order to have a real-time traffic flow, road surface sensors in conjunction with CCTVs may provide real-time updates. And this information could be made available on user apps about congestion and traffic signal malfunction. Even smart controllers may automatically make real-time traffic light adjustments responsive to the traffic conditions in real time. For water quality, we may deploy sensors across the water grid to measure pH value, to measure dissolved oxygen, dissolved ions. We can connect them with the cloud platforms, and if there is any abnormality in the chemical composition, it will generate the trigger and we can take the maintenance action. Extending to the air quality, we can collect the data on CO, nitrogen, sulfur oxide, and we can map the air quality. There is a very interesting example of Hong Kong City. They have used lampposts, and these lampposts are termed as smart lampposts with multiple sensors, multifunctional lampposts. They measure the traffic conditions, monitor weather and air quality, and they also track waste dumping. But the issue regarding these all matters is related to the implementation on the ground level. See, in our country, we have a very ambitious smart city mission started 7 years back, and we have taken 100 cities in first phase with huge financial outlay. The challenges in realizing this dream of a smart city involves many. But I want to share just 2 observations. My first observation is that we need to provide a rugged, reliable, secure, and high-capacity digital connectivity in order to realize this dream of smart city. And for this purpose, we must fast-track the deployment of 5G technology. We need fiber-like access data rate for the users for smart city amenities, and I think 5G technology can provide this capacity. My second observation is about air pollution in our cities. That has become fatal. AQI in Delhi nowadays is 450 crossing. And as we know that the mission of a smart city aims at quality of life. But for quality of life, our very first need is to have fresh air to breathe in and clean drinkable water. There is air emergency in Delhi and NCR. Even additionally, the 11th Sustainable Development Goals from UNO talks about sustainable cities and communities. So it becomes imperative to devise some innovative solutions to tackle this one of the most serious problems for ensuring sustainable quality of life to the citizens in these intended smart cities. I'll ask or appeal the researchers and scholars to go through IEEE COMSOC standard development boards. These development boards are covering state-of-the-art emerging technologies and industry communities, and they are highlighting certain promising solutions to the challenges of smart city implementations. I've seen the schedule of the symposium. Very interesting talks have been planned during the symposium. Even I was listening to this speaker just before me. They include metaverse, smart cities with AI, building digital twins, so on and so forth. I'm sure all the participants will be immensely benefited, and it will help the young researchers to get insights and formulate their research problems in line with the real problems of the society. Thank you so much. Thank you, Jan.
We are waiting for our founder chairman, sir, Dr. Nankushore Garg, sir. He will be arriving soon. So just wait for a few minutes. So students, I just want to say a few words before our founder and chief advisor arrives. That all of you, most of you are participating in Smart India hackathons, both hardware as well as software. So the smart cities, it is a very smart topic and something which is going to be the future. They talk of the previous two speakers were extremely good. They have thrown ideas. So you students, you can just focus on these talks. ये जो 2-3 दिन में talks हो रही हैं, जो paper presentations हो रहे हैं, you sit through it and you focus. This is what is this is how you can get an idea. आप कुर्सी पे बैठे हैं, कुछ सुन रहे हैं, बार-बार किसी चीज को सुन रहे हैं. And suddenly something strikes. And when that something strikes, you can start working upon that something. The moment that something strikes, you can start working upon that something. And once you work upon it, you become an innovator, you become an entrepreneur. So this is what I want you to do today. Ki aaj aap just sit back, relax on your chairs, but sit, you just don't talk. You keep your ears open, your mind open, your eyes open, and you listen to the speakers throughout the day. You are going to get a number of ideas, a number of, papers, 20 papers are going to be presented. of the level of, the papers are going to be of the level of those which are going to go into the frontier journals. So good lot of papers, faculty is there from our institution, from other institutions, and a number of ideas, number of presentations, number of skills will be thrown upon. Okay. So smart cities में you can start from a small home, छोटा से कमरे से आप start कर सकते हैं. Then it